I'll be keeping one. I've got a couple of monitors set up over here, so I'll be keeping an eye on. Thank you. I'll be keeping an eye on Discord if anyone has any questions, silly comments, or whatever that you'd like to do. So feel free. I like a bit of interaction, so please feel free to banter. I'm happy enough to respond to anything. Teams. Oh, okay. David Glass says the teams are on a slight delay compared to Discord. Fair enough. That's why it took a minute. That's no problems. Okay, I can go steady. Here are my contact details on the screen at the moment, by the way. So if anybody has the strange idea of wanting to get in touch with me beyond today, then feel free at any point. And if anyone can recognize the film on the right there, the screaming face thing, you can automatically be a friend of mine, because that particular film's a guilty pleasure of mine. I can't entirely defend it, but I rather like it. So we'll get cracking. Get the mouse on the right bit. Hey, there we go. Right, a little bit about me. I won't spend too long boring everyone with this section, but I've been doing IT for quite a long time now. About, I think 16 and a half years, something like that. I've been doing C# development specifically. I started with a little local group in Telford, which is where I live. We're doing applications for local bus services for councils, and that was great because the only way to test it was to get a mobile device and go for a walk in the park, because what I was doing was the mapping systems. This is in the days before Google Maps, when you actually had to hard code, you know, your own maps with map files on devices and stuff like that. It was great fun. Worked for Capgemini for a bit, doing some government work, the Works, the Book Place, and Protolabs. They're a great place to work in Telford if you're ever needing a job this way. I was briefly one of those contractors that your mum used to warn you about. And these days I work for Muller Dairies, the folks that do the yogurt. And when I signed up, I was promised free yogurt, but I haven't received any yet because I joined during the pandemic, and so I haven't actually been into the office yet. I've worked entirely from this home office here, which there are worse things I could be doing. I'm just going to open the curtains, honest, I think. Yeah, I hope anyone can see me better now. Not that it matters a great deal. But right, that's enough about me. This is the gentleman we're going to be spending a little bit more time talking around. This is Uncle Bob Martin, as he's popularly known. He's written a whole load of books on software design and video series and all sorts of awesome stuff. And it was him that coined the solid principles. He didn't necessarily invent all of them. One or two he did, but some he didn't. But what he did do was put them together in a coherent order and gave them a rather snazzy name. that's a little harsh, Mihailo. They're a very nice company. They're nice people. I just wouldn't say no to some yogurt. Right. So there are 5 principles, and there are actually more principles. I found the original paper that Uncle Bob wrote. There were a whole load of other principles involved, but the others were more involved with stuff like the deployment and release processes and stuff like that. There were only 5 that were involved with the design of an object-orientated application, and those are effectively the 5 that have stuck, because when Uncle Bob wrote these, well, I think to this day probably he was a C++ developer, and was more concerned with the lower levels of messing with C++. And it was an era when the deployment of DLLs was a potentially expensive process, and to some extent that was what he was trying to avoid. The Cake Monster, have they not heard of the concept of home delivery? They probably have. They mostly actually they do have a home delivery service, but I don't think it operates in my area. Unfortunately, I think it's mostly down in London. So I'll live for now with the knowledge that one day I might possibly be able to have my home delivered yogurt. You never know. I quite like the chocolate one with the the vanilla one with the chocolate sprinkles. If anyone's ever buying, that's a nice one. That one, right. So back to solid. So these are 5 design principles, and they're not the only ones. They're not even the only sets of design principles, but they're pretty good ones. And if you follow these, you're likely to be coming up with a design that is, if not brilliant, at least reasonable, or at least not terrible. I've been doing this for quite a long time, and I've seen some really bad code. Nobody I currently work with is responsible for any of that, by the way, in case they're watching. But I have seen some appalling code over the years, and an awful lot of it could have been solved by just paying attention to these 5 guys here. So that's what I'm going to be talking through for you. Now, when I say I work for Muller, I'll let you in on a little secret. In fact, I secretly work for the Galactic Empire, as in those guys from the documentary series Star Wars, which you may have seen. That's our work. That's what we do. We're a sort of manufacturing company. What we do is we take in planets as our raw material and we convert them into radioactive rubble. That's what we're in the business of. Or we take rebels and turn them into, well, not rebels anymore, shall we say. That's what we're up to. Okay, and these are our guys. Wave, guys, wave. They never wave. They never wave. It's funny, they never wave when they're a photograph, but there we go. And these are our opponents. These are the rebel scum. And what we want to do is devise some systems which will help our guys to defeat these guys. Easy peasy. We've had a few goes at this over the years. The very first project was this one. This was Project Death Star. It was pretty good. We got it working. We got it out of testing. We delivered. Everyone had a big party. It was great. Went into production, and a day or two into production, we had a few technical problems. There were a few flaws. Probably should have tested it a bit more extensively. What can you do? It happens. So then we went on to version 2, Death Star version 2. So this one was fairly good. This was even bigger than the first one. So clearly the CEOs had some great plans for this in mind. Unfortunately, didn't quite survive the testing process. So back to the drawing board. In fact, that was such an absolute shambles, to be honest, that we had to change CEOs. It was a bit embarrassing for everybody. We all cried a bit. I did. So we're being unable to solve this problem. We have gone by the traditional political route of giving it a new name. So we are no longer the Galactic Empire. We are the New Order. All hail the New Order. That's us. And of course, having had an opportunity to rethink and plan over the years, we've of course gone with a whole new, radical, different, another Death Star. Totally the same as all the others, except this one's yet again even bigger, because that's the way forward. So fine. What I'm going to be doing is talking through our design principles and how they apply to our giant planet-killing weapon. So, the actual solid principles. Good. S. Single responsibility principle. So this one gets misquoted quite a lot. A lot of folks seem to think that this is everything should have only one reason to should do only one thing, which is not what it is. It's actually everything should have only one reason to change. Every module, interpret module in the way that you wish, typically as class. But now, before we start, I am a C# developer. Consequently, my examples are all sort of vaguely C#y code. They're not real implementations. There's not going to be any solid C#iness behind the surface. It should be stuff that will be familiar to everyone who's worked with an object-oriented language in the past. So certainly Java guys will find it suspiciously similar. But just so you're aware of that before we go forward. What's this? Steve Fenton says you believe it was Soldy until Michael Feather spotted a better acronym. Could be. I don't know. It's certainly solid sounds a little bit better. It's a remarkable coincidence it spells that word. And Mark started with, depends if the test goes like this. Given I have a Death Star and I have a vulnerable reactor, when I blow up the reactor, then I should see a pretty explosion and I should post new vacancies on LinkedIn. Well, since I work for the evil empire, I don't want to see the pretty explosion, excepting that the pretty explosion be one of the rebel ships. That is acceptable. So I think it should be, given I have a vulnerable reactor and the rebels are attacking me, they all blow up. That would be much better for me. Anyway, moving on to the single responsibility principle. Let's imagine for a moment that we're putting together a targeting system for our Death Star. So we'll have a little stroll around the work floor to ask all the different teams who are going to use this thing, what do you want? Great. So these are the scanner operators. That's what these guys do. They look at the scanner, and everything they see on a scanner that needs to go on the list of potential things that we want to incinerate, they press a button, it goes on there. So they need a function which is add new target. Great, and that'll add it to the list of potential targets for later use. This guy is my moody DBA. There he is screaming at us for the misuse of indexes that we often seem to manage. And now I did say that we are an evil empire, so we use Entity Framework as our database communication technology. And that means that we need a save changes function, because Entity Framework, for anyone unfamiliar, it's an object relationship mapper. It kind of gives you an in-code way of interacting with database entities, and then you have to save changes to actually commit to disk, as it were. So that's what that's all about. So it requires it. It requires it because we use Entity Framework. Okay, let's have another stroll around. This is our gunner. Her name is Marjorie. Don't make judgments, guys. And she needs to select from the list of targets, select one, and then incinerate it. That's what we do. Right. So she needs lock on target, and also probably we need to find out what the current target is. So that's a whole load of stuff in our targeting system already. And finally, these are the UI guys, and all they're concerned with is, here's our targets, we're going to render it into some lovely form that people can actually look at. So they're going to add in something that's generate all the HTML for all the targets, and while we're at it, we'll probably shove something in. So what's wrong with all of this? What's wrong with all of this is that we've got one gigantic class which is serving 4 different areas of the business. Now, in a real world, it could be any number of areas. I'm just making this up whole cloth just to give you an idea of what could happen. But the point is that if the database guy makes a change to the way the Entity Framework works, or a change to the database, or decides that we're going to all switch to Dapper, whatever, then that means a change to the targeting system itself, which is dangerous. We are an orbiting gun platform, and so a targeting system is probably just about the second most important feature of our computer system, despite other than say the gun. And without the targeting system, the whole business is at a standstill because we cannot shoot things. So any changes to the targeting system, which could result in an error, those are incredibly dangerous changes. We want to touch the targeting system with extreme levels of caution because it's just that important. And the fact that there are 4 sets of business groups with fingers in this, that means there's 4 times the number of potential changes going through. I mean, in my imaginary scenario, even a change to the way that HTML is rendered would result potentially in a change to the targeting system. And all of this is a fairly unacceptable level of risk. Now, I believe the original change, again, going back to the original paper, he was more concerned with the shipping of DLLs and stuff. But in the modern age, I would say we want to treat changes to our system as being risky in and of themselves. I mean, if we're being good people, then we should be unit testing all of this, and that reduces the risk somewhat. But then unit testing is not a perfect operation, and it'll never necessarily catch literally everything that could ever happen. So to save ourselves from this risk, to reduce the level of problems that we could have, then it is best to just split this down by business areas one way, or by reason for change. Business area is as good as any for now. There could be other reasons you might want to split it down. So the targeting guys, they'll have anything to do. I've given them a repository, for example. These are just arbitrary splits. We could do this any way we liked, and that's just going to be getting and adding targets. I'll give them a unit of work. It's as good as anything. This represents an operation to save a database change. I'll give her stuff to do with the current target. And these guys, they can just have the HTML generator, and this can even take in the current set of targets. So as just straight out as an enumerable, that is kind of an array for anyone not doing C#, and that would mean we could totally test the heck out of this thing in isolation. So we've already given ourselves a little extra testability and maintainability just by splitting things up this way. So it ends up looking like this. We've got, rather than having one gigantic class, we've got 4 little ones. We can test each one far more effectively in isolation. And on top of that, each business area isn't tied to the others quite as strongly and isn't subject to the same levels of risk from other departments' changes interfering with what we're doing. Mark Stotts put a picture of some of his micro Death Stars he made, and those are pretty sweet, I'm going to be honest. Although those are, what are they called? It's not Star Destroyers, I believe, aren't they? Oh, I see. Sorry, I didn't see the cake monsters. The main problem with Death Stars, it was monolith. Yeah, I suppose that's a good point. I shall bear that in mind for version 4, but for now the business are pushing for the gigantic planet-sized weapon approach. And hey, I'm just the engineer. So moving on to number 2. This is the open and closed principle. So this is a principle that a module, again, I tend to interpret this as class, although it could be function, should be closed for modifications and open for extensions. So to go on to my Star Warsy demonstration, this is one of our rebel enemies that we want to fight and incinerate. And we're going to write a battle computer to go in our ships that will help us to blow all of these guys up. Is the old version of the battle computer. At the moment, it doesn't do any fighting, which is a bit of a shame. So that's something we need to add in. It can do some flying, it can spin around in a barrel roll because we're cool, we are, and we like to do some stunts because that's the sort of guys we are. So we need to add in fighting. There it is, some fighting. So it's fight an X-wing. We'll pass in the X-wing object, whatever that might contain, and we'll fight it. I presume this will contain all of the instructions necessary to maneuver, to lock onto the thing and just blast it. So that's fine. There's nothing wrong with this as such. But the problem is that the enemy over there, they don't just have one kind of ship. They got several. There's a selection of the others. Now I happen to know that the one on the left is a Y-wing because I used to actually have that toy when I was a kid. It was awesome. It didn't look quite as good as that one by the time I was finished playing with it, but hey, it was a pretty neat little toy. It's a B-wing in the middle, and I'm not entirely sure why the heck that's called a B-wing because it looks nothing like a B. I'm guessing they just really had totally dedicated to the letter wing thing by this point, and they had to come up with something. And on the right's the Millennium Falcon. So cool. Now we need an additional function for each of these guys. So there we go. Now this seems fine on the surface. We've got a function to fight each of our potential enemies, and all seems well. We can go ahead and unleash the metaphorical hound slash TIE fighters. But the problem is here that every single time that we want to add in a new enemy, we're going to have to re-release the battle computer. So if the rebels invent an entire new kind of ship, which is entirely likely, or then we're going to have to modify the battle computer again, and we're going to have to do a release. Now, since this is going into our TIE fighters, which effectively means it's a distributed system, it's a form of IoT, I suppose. They're flying, and we're going to have to go and release this thing to each and every single one of these, and that's really expensive. And on top of that, we're talking once again about modifying an incredibly business critical class, something I would really rather we left alone as long as it's working. And that's also not great unless we really have to. We might have to on occasion, but if all it is throwing a new ship in, then that's not so good. So this is not an ideal scenario. So what we can do is create an abstract class, call it enemy fighter, and what I will probably have is a single function inside my battle computer, which is something like fight enemy fighter, and I'll just take out each piece of that big function, which is going to be different every time, depending on the class of ship that we're fighting, and then abstract those out into this generic enemy fighter abstract and put those details into here. And then probably it's going to be largely the same for all of these, X-Wing, Y-Wing, B-Wing. I'm saying that those are just straight off inheriting from the original. Now, I think these are virtuals, by the way. I don't know whether I'm preaching to the choir or not, but I don't know if everyone's happy with what a virtual is. At least in the C# world, a virtual means that there is a default implementation in our abstract class, but you can override it. The alternative to that is an abstract method where there is no implementation and you are forced to implement it. But in my imaginary scenario, the only real significant difference is if we're fighting the Millennium Falcon, in which case there's a different firing location. And this is great. So what it means is that in potential, we could stick each of these into different DLLs if we wanted to. That's good. That makes shipping out easier. Or if nothing else, it means that whenever we modify the system to incorporate a new kind of enemy, then we don't have to touch the original battle computer code. All we do is write a new one of these with either just straight out implement, straight out take all of the virtual methods from the parent class, or override where necessary. But it's not that big of a change, and the risk to the original class is low because we're not touching it. Now, we might still need to go in there once in a while if an entire new method of fighting is discovered, but by and large, this is fine. And this is much lower risk than going in and touching the battle computer code in its original form. And there you go. Looks kind of like that, for example. That means that the battle computer code now is, well, it says closed for modification. It's not entirely, of course, we may need to, but it's more resistant to the necessity for changes, because we've got this abstract that we can extend elsewhere. So it's saying that you go ahead and make as many classes enemy fighter as you like, and it's all fine. We can accept them here in the battle computer without modification. And this is good. This is a much better way of working. And a note at this point, by the way, to just clarify two concepts, and getting these two confused is at the heart, I think, of some bad software design, and that is inheritance. That's a pretty meager inheritance if it's just a little model house, I think. But hey, it was a picture I found on one of the stock sites somewhere. But inheritance represents what a child class is, what it actually is and embodies fundamentally. Inheritance is decided at design time and can only be modified at design time. And that's not to be confused with composition. A composition is what we have, not what we are, but what we have, and that is decided at runtime. This is another look at an open-closed implementation where we're talking about the two concepts in parallel here. So fightercraft is what the TIE fighter is. So it inherits from presumably an abstract class or something called fightercraft, and it has weapons. That's my composition. So in my case, again, I've gone open-closed on this, and they're projectile weapons taken into completely abstract terms, which just fire. And my TIE fighter or fightercraft don't need to be concerned with how these operate or what they are. So in my example here, it could be a laser blaster, or it could be a Wild West style 6-shooter. It's all fine, provided that the implementation is done correctly. So that's all fine. That's right. And this could even be hot swapped at actual runtime, because it can accept any implementation of projectile weapon there, and that's all good. If you want a car example, then I suppose car is what a race car is, as in that's its inheritance is car, and then what it has is wheels, and wheels can be swapped during a race if necessary. So those would be composed in rather than inherited. So important concepts to bear in mind. The Liskov substitution principle. Now, this is definitely one categorically that Uncle Bob did not write himself. This was invented in 1980, 8, I think it was, and it's often referred to as the Liskov substitution principle, but there were two ladies who were behind this one. It was Barbara Liskov and Jeanette Wing, and I believe they came up with this together. I think there was a paper that was written, I don't know, I haven't gone and tracked it down, but anyway, strictly speaking, it's the Liskov-Wing substitution principle. The examples you see around the internet tend to talk about ducks, and there's an old adage, I may as well bring it up because it is nice and illustrative, but it's something like, if it looks like a duck, quacks like a duck, and acts like a duck, it's probably a duck. But if it's yellow and made of plastic and takes batteries, something's gone wrong somewhere, and you may have made a mistake in your abstractions. So it's all about trying to make sure that the child class actually matches the abstraction that we're pushing onto it. So I'll go back to my example. So I'm going to imagine for a moment that we're making some sort of automated system for fighting hand-to-hand combat, because upon occasion the rebel scum make it through our defenses and inside the Death Star itself. So we could use stormtroopers, but I don't know if you've ever seen those guys shoot. Don't tell them I said it, but they're not great. So an automated system would be much better, and we want to be able to hand this thing all sorts of weapons like these guys. Now, I didn't actually know the names of these weapons. I had to go and look it up on Wikipedia, which I can't decide is either one of the best or worst named websites ever. Wikipedia, that's quite cool. But anyway, two different kinds of blaster rifle. Fundamentally, if, let's say over there were a large enraged Wookiee charging towards us, the process of discharging one of these into him to defend ourselves is not fundamentally very different. We pick up the weapon, we activate it, however that might be, probably pressing a button, aim it and pull the trigger. That's our activate, actually, sorry, but it's pulling the trigger. That's all we do, activate the weapon while aiming. Easy peasy peasy. Hopefully the enraged Wookiee becomes either pacified or something else. So no problem so far. We can extract out an interface for this, which would help our following our open close principles, and that's great. And then we could call it weapon. I probably should have called it iWeapon, come to think of it, but hey, it doesn't really matter for this. It's not like I'm really releasing this to production. So that's fine too. So that means that when we're dealing with our automated fighter, we can just pass it weapon, and that could be almost anything. There's no problem yet. But what if I wanted to hand it a lightsaber? Say, yeah, we have them, we got them, sure, we got them too. Now it can actually implement this interface, that's fine, but aiming, well, okay, we can aim, we can point our lightsaber at the Wookiee and activate our weapon. Okay, that's pressing a button. That's fine too. But have we actually done anything useful? In fact, we have not. We've done absolutely nothing useful whatsoever, because all that's going to happen is, unless this system is going to be given any further guidance, the Wookiee will simply sidestep and run around our lightsaber, because all we've done is take an aim and pressed a button. If this were a blaster rifle, this would have done something, but it's not. So what's happened is we're getting unexpected behavior from an implementation of our interface, which could be used in production without an actual crash, but it's still not going to result in any behavior that's of any use to us whatsoever. So something's gone wrong with our abstraction. The way to solve this one would be to have two different interfaces and two probably whole different families of handling of weapons. So our close combat weapon, yes, sure, we still have an activate on it, and we can raise it, slash it, parry, all this sort of stuff that's useful to do with the lightsaber, and that's a separate family now of implementations from our blaster rifles. Is everyone following so far? Just shout out if anything's not making sense. And we could take this a step further even, and we could create an abstract class called weapon, and then now we've abstracted out activate the weapon into something, and this actually massively reduces the amount of code that we need to write, and that's great. So they all have an activate weapon, so probably it's going to be some variation on pull, press a switch. There might need to be a new implementation of that for lightsaber because I think it's a button rather than a lever, but fundamentally though it's still the same. And this means that we can also have an abstract ranged weapon, an abstract close combat weapon, and that reduces the amount of code in lightsaber and the various different blaster rifles to nearly nothing. This is great too. And we may as well sew in a deactivate weapon, and that's good because why not? That's for the close combat weapon. Doesn't make sense for the over for the blaster rifles because you don't deactivate them as such, you just pull and we're done. But we've still got a further problem that could occur. What if we were using an axe, as demonstrated by our gorgeous model here? An axe is a close combat weapon, and so things like the parrying and the slashing and all that makes sense. But our activate and deactivate actually do nothing. And now that it's an abstract, I'm either going to be passing code in that's expecting the presence of a button, or forcing an implementation of something that there is no implementation for. What we're going to end up with, we get probably some sort of rubbish scenario. We are either going to have to put in a blank implementation here, which does nothing, and it's just a waste of everyone's time, and it is going to potentially cause some unexpected side effects when someone is dealing with close combat weapon in the abstract, not realizing that some of these functions in some cases don't do a thing. Or you might even get an exception because it starts looking around for a button that doesn't exist. Now, in the C# world, I believe there is a quick and easy way of doing this, and I'm trying to remember what it was. It's something like have a variable of type IEnumerable, let's say string. No, it's not that. It was iCollection. That's it. Create a variable of type iCollection string, and then instantiate it as an array, as in just a straightforward array with open closed square brackets, and then try adding something to it. That will actually compile, that will run, but you try adding something to it, it'll crash out horribly. I don't know whether that's still the case as of as in the latest all singing all dancing C#10. I don't know, but certainly historically that's always been the case, and that would be an absolute break of the Liskov substitution principle. So hopefully we're all clear on that. Are there any questions at this point? I'm having a quick peek. I don't see any messages for a while. Okay, I will push along. Now, interface segregation principle. We're nearly done now, so then you can all go have your coffees. Yay, coffee. What's this one? Let's imagine that I'm putting together an interface for droid. Now, there's all sorts of things that a droid can do. It can fight and defend. Believe it or not, droids on the quiet are all rock fans, and most of them can play an absolutely flawless rendition of the guitar solo from Stairway to Heaven. This is an established fact. Absolutely. Speak bocce, sure, they can probably all do that. Why not? And Carol in Bushes, they can do that too. So that's all fine. We can pop this implementation out, and all our droids can do all of these things. But here's a couple of droids that we're going to pop this implementation down to. This is, I can't remember his name and I'm not really interested, but he is a bounty hunter droid. Now he can do all of these things. He absolutely can. Sure, he absolutely, why not? He can fight, he can defend. He definitely can play Stairway to Heaven. I've seen him do it. And beat bocce, why not? And Carol in the Bushes, he could literally physically do that if he wishes. Same with this guy. He could definitely do the last two. Fighting and defending, sure. He might not be very good at it, but he can do it, and that's the point. And then there's these guys. This is these aren't entirely Star Wars, but these guys can definitely play Stairway to Heaven, I'm sure, and probably do all those other things. I've no reason to believe that they can't. So all of these people can do all of these things, probably. And that seems fine. It's not entirely a break of the Liskov substitution principle because they can. You won't necessarily get any unexpected side effects, although asking C3PO to fight will probably not result in great things, but he can try doing it if you really want it. Oh, Mark Stott says he wants blue milk and also it's IG88. That's I probably should have known that because I even had the action figure of this guy. Although I think the dog got his teeth on it, took it out to the garden and chopped it to bits. IG-11, oh, I don't know. I'm not going to pretend I'm enough of a Star Wars fan to know. Honestly, don't tell anyone, but I'm actually more of a massive Doctor Who fan. But Star Wars is pretty universal, which is why I've gone with this theme. Right. But my point is that they can do all of these things if we so ask them. But the real problem is, would you ever be in a scenario where you'd want something that can do all of these things? Are there any software systems out there that would take a droid where you'd actually want this full range of droid behavior implemented? And the answer is probably not. Oh, got a duplicate slide there. That was clever of me. The reality is that you're probably going to have a combat system, and all the combat system is interested is the droid's ability to fight and defend. And I mean, sure, the droid can totally play Stairway to Heaven, that's true, but it's not useful to the combat system. It doesn't need that function. It's useless. Similarly, the combat guy system is not interested in the droid's ability to cower in the bushes, even if it's a thing they can do. I suppose that could loosely be classed as defending, but there's probably far better ways of doing it than that. Our entertainment droid, let's say, is going to be plugged into an entertainment system of some description, and it's not interested in the bot's ability to fight, even though it can. A rock concert going on and then triggering the fight system is probably going to end not well. It's the same with the interpreter. The interpreter doesn't need the ability to play the guitar or the ability to fight. That's not what it does, at least not while it's wearing this hat. Now, it could well be, stating this again, that all of these guys can do all 5 of these features, but it's more like they have different hats, and when they are performing different roles, they are being seen in accordance with which hat they're wearing. So if this is a combat system, you are only interested in seeing combat stuff. We're not interested in seeing the rest of it. Now, it could actually be in the real world that these are all split into literally separate classes, or it could be that these are only 2 classes, or it could be that there is one giant class that implements all 3. And all of those scenarios could be potentially fine, but we don't want to be forced down the route of definitely having all of these in one gigantic monolithic class. That wouldn't be good. We'll be forcing us to keep them all together with all the various functions crossing over each other, sharing data structures, who knows what. We've got one massive system being used, one massive class being used in 3 different systems, and again, we're back in a scenario where we're inviting breaches of the other principles, things like the single responsibility or Liskov substitution. Strangeness could occur. It would be much better if we passed around split down little interfaces which are specific to the point. In fact, if there's one takeaway for this whole process, it would be keep your interfaces small and to the point. That would probably be the #1 tip. Also, does anyone ever notice that C-3PO has got 1 silver leg? You are welcome. He does. Mark Stott says IG-88 is in every Star Wars Lego Christmas calendar. That's pretty cool. No one's ever got me a Star Wars Lego Christmas gift calendar. That would be cool. Oh, and the other one's from Mandalorian. I haven't seen the Mandalorian yet. My wife does not care for Star Wars, and I haven't yet managed to convince her to watch it, but I'll get there someday. Right. How are we doing for time? We're doing pretty well. We're doing pretty well. So there we go. Keep the interfaces small, keep them to the point, keep them split based on what they're required to do at the moment. So let's finish up with talking about the dependency inversion principle. I would hope that this is the one that everyone's going to be the most familiar with these days, because this sort of thing has become baked into an awful lot of modern coding environments. Certainly, if you've ever worked in .NET Core, which I do quite a bit, then dependency inversion is baked into that from the beginning. Certainly, if you work in ASP.NET Core, you pretty much have to interact with a dependency injection container. A dependency inversion principle is different to a dependency injection container. The container is what injects. The inversion principle is just that whatever it is that your class needs should be passed in. So let's see what that looks like. So this is our gun code, and I did say that the targeted system was our second most important business critical system, and this is the most, because what we are building is a giant orbital gun platform, and so the gun is the most important bit, and so this is the bit we want to take the most time over, making sure it works well. And I completely made this up, I think, but I'm imagining that it's got a type 42 plasma converter on it. Sure, why not? Absolutely. But what happens when we want to switch to type 43? Well, we're going to actually have to modify the code, and that's not good, because this is the most business critical class in our whole flaming system. We don't want to touch this thing. We want to be on absolute best behavior whenever we go anywhere near this class, because any break to it, any change that could introduce problems to this class will result in basically our giant orbital gun platform being a nice pretty thing up in the sky that rebels can use as targeting practice. That's not good. So that's not great. We can't change it. We can't upgrade this thing without passing in, without re-implementing this. So the other problem, and I think this is one of the ones that's keeping this very relevant these days, is we can't test this in an automatic manner. We can't unit test this because we're actually instantiating a real plasma converter inside our class. We can't run an automatic test unless you want to pass in a real actual plasma converter, which might really fire the giant planet killing gun in a test scenario. Now, I'm not averse to incinerating the odd less worthwhile planet. There's plenty out there. But we're going to run short of those if we continue to do these tests. So this isn't great. And this is what the solution might look like. Now, hopefully this is going to seem fairly familiar in principle to an awful lot of you. And that's that we abstract away our plasma converter to an interface, which again is now following our open close principle. And we are going to pass it in rather than instantiating it locally. So whatever it is that contains gun will tell gun which is the current plasma converter. Now, there's a common misconception that you have to use an IOC as in an IOC container. You don't. You can follow this principle without using one at all, and I have done this. Occasionally, I've written things like little console applications and one or two other systems like that where they were so small that there wasn't much point in grabbing a copy of Ninject or Unity, or what is it? Not Unity, yeah, is it? But anyway, whatever the Microsoft one is, there wasn't any point to it. Why bother introducing all of that additional stuff when I could just instantiate an object and directly? So in my case, I would literally instantiate a gun and just then instantiate the plasma converter I want at the top level, but not inside the gun. That is the point. The gun itself does not decide which converter it's got. It's the layer above it that passes one in. So we're still following the principle in that case. Although if it is a large system that you're dealing with, and particularly if it's something like ASP.NET, you totally do want to use an IOC container. That's absolutely what you want, because there's just going to be too much complexity and too many things. But still, you can follow the principle even if you don't use a container. That is fine. But the bonuses we've got here now are, if we want to upgrade this thing to any version of the plasma converter whatsoever, we can now potentially do it at runtime if we wanted to. We could certainly do it without any real effort at design time, and we can test it by passing in a mock implementation of iPlasma converter. So if we want to test this completely safely, we absolutely can. In the .NET framework, we use things like mock, that's MOQ. And I'm sure that the Java world has got similar things. I don't know. I'm not a Java developer, but sure. But it means that we can run automated tests, which guarantees better quality software, more robust software, and also we've got more adaptability during runtime, which is all good. That's what an IoT container looks like in This is the .NET version, by the way. You do things like you can even configure logging, so you can configure what sort of logging you do straight at the beginning. You'd stick this somewhere right at the beginning of your application, and that would configure in what are the real implementations of everything. And you can even go steps further with this stuff, where if there are like 3 things that potentially could be the implementation of choice for any given interface, you could write a bit of code that will select which of those implementations it is that you want to inject into the receiving class every single time that you instantiate one. And that isn't something I do very often, but there are the odd circumstance where you might want to do that. But it's another tool in your belt that you can have by following this principle. So pretty much coming to the end. Any further reading? You can't go wrong with reading anything by Uncle Bob. As I've said before, he didn't necessarily invent an awful lot of these ideas, but what he is really, really, really quite good at is being a communicator of what is the software architecture community thinking at the moment. What are, as far as you can tell, some of the very best practices, and he's probably the first port of call for understanding where the industry's at the moment. He does do a blog, cleancoder.com. He's even got a clean coding video series, which is quite fun, although be warned, it is the information on those videos is great, but it is done in his inimitable style, including things like Sherlock Holmes costumes and wild wigs and stuff like that, because that's the way he works. If you want to take it a step further beyond Solid, there are the design principles. These books are worth a go, although I wouldn't necessarily sit down and implement every single flame in one of these. And certainly the book on the left, that's a book to dip in and out of. It's not a book to read cover to cover. And some of those patterns I'm not sure are necessarily relevant today, but probably starting with the O'Reilly book on the right is going to be a better place for you. Oh, and that's my bit done. We've got about 10 minutes left. So I'm going to take a couple of moments to take a swig of cola. Does anybody have any questions that I can answer at this point, or are you all in an absolute stunned silence? I'll give you a moment because apparently there's a delay. Oh, I needed that. Cake Monster's flapping his head at Wikipedia. Totally true, that. I'm all for terrible puns. They are the sign of a truly advanced civilization. Okay, got some more typing. I miss live speaking. If any of you guys happen to be virologists, could you please hurry up and get this pandemic over with so that we can all go back to speaking in person again? I miss it. Oh, Philip Ersglove, forgive me if I don't get names right. Dan North has come up with an evolution of Solid called Cupid. I will have a look at that. That sounds interesting. I've not heard of it. This is the first time hearing of it, but I shall certainly give that a look. There's a link there in the chat for anyone that wants to see it. So that's definitely going to be a read for me. The Solid principles are quite old. I mean, they date back to the 1980s, and they were developed according to somewhat different pressures than the ones that we face these days. They didn't have automated deployments. They didn't have unit testing. I don't think so anyway. So it could well be that there's some updating to be done. I don't know. There's certainly still, I would say, fairly good guiding principles if you're just trying to put together a half-decent software system. You're not going to go wrong by following these guys. Oh, no, thank you, Huddy. Again, apologies if I'm not saying names right. Mark Stott says, looks like someone really wanted to spell Cupid. Yeah, probably. Do I know of any typical gotcha scenarios when anyone attempts to follow Solid principles but doesn't get it right or misinterprets it? No. I'm going to be honest, the main problems I ever see out there are when people clearly don't know about them or never bothered. I've never seen anyone try to and get it wrong. Steve Fenton says, thanks for arranging this content into such a very entertaining form. Thank you. You're most welcome. I mean, in terms of problems I tend to see out there, obviously not following dependency inversion is still a massive problem. It's still surprising how often I see that. The other one is things like not dividing up the class. I worked in a place some years ago where they had like gigantic monolithic classes that were several thousand lines long, and that's ridiculous. And it was absolutely unmaintainable. I thought, I know, I'll just grab this little piece off here of this gigantic class and see if I could just devolve this into its own little thing. And it was like pulling on a carpet thread. It was like, oh, I'm pulling. Oh God, this thing is getting bigger and bigger. What the heck? And in the end, I just gave up and reversed out my changes and had to just leave it as it was. It was an absolute flipping shambles. Oh, you're welcome. Deanna Shaw. Sorry about the names, but thank you. I don't know what these hashtags and numbers are. Oh, and thank you, the Cake Monster, and thank you indeed for cake. I presume you are the guy that invented cake. I'm going to assume so because cake is good. We've got 5 minutes left, guys. I'm going to stick here for 5 minutes and I'll carry on looking at your comments for those 5 minutes. But if anyone still has questions after the 5 minutes is over, then reach out to me on, well, I'm here, of course, on Discord. I'm on Twitter. Unfortunate violations of the Liskov substitution principle are always a danger, I'd say. It can be more subtle than others. It's probably true. That is probably true, the Cake Monster. Yeah, probably, if I really thought about it, I could probably think of some really dodgy code that ended up sort of being botched in just to get around those problems. Michael Monk, thank you. Oh, thank you, Michael Monk. Scary looking. I do. I'm sure you're not. I'm sure you're not. Thank you. That was really interesting. The way you presented using Star Wars analogies made the concepts easy to digest. Oh, thank you. I didn't want to go with oh, this is everyone. I didn't want to go with real world scenarios because I thought everyone is going to get very bogged down by the real world detail of this manufacturing process or whatever. I thought if I just conjure it up out of my imagination, then we can kind of let go of that a little bit. Okay, it's everyone entering the prize draw. That explains it. How do I enter the prize draw then? Oh, thank you, Edward S. Oh, the best way you've ever had solid that's very kind. Oh, thank you. That's very kind of you indeed. And the Cake Monster did indeed invent cake. Well, thank you, sir or madam. That is brilliant because cake is the best thing ever. Aside from coffee and cake. It's a magic combination. Thank you, David. Cheers, AC. Oh, I think this is only actually my second proper talk at a conference this year, which is low for me, but it's better than I was expecting considering, you know, pandemic and all. I even got to do one. I don't know if anyone was at DDD East Mids, but I managed to make it to that one. There was a slightly early version of this talk, solid overview. Ah, a pun. I like it. I did manage to do a slightly early version of this, but this is the marginally improved version, which I'm feeling a lot happier with. Oh, thank you, Ian. Yeah, I kind of enjoy the Star Wars theme. Star Wars is universal, isn't it? Even if you've never actually seen Star Wars, I think you're going to understand. You're going to have picked up enough by cultural osmosis to understand what I'm talking about. And it's not like I'm really properly following the Star Wars mythology anyway. That was fun. Got 3 minutes left, guys. I don't know if anyone's still around. I'm not seeing any more comments, but I'm still sticking around for 2 more minutes. If anyone hasn't seen it yet, check out He-Man Revelations on Netflix. It's fantastic. Also, Cowboy Bebop, the original. I have just discovered it for the first time, the animated one from the 90s. It's great. Oh, controversial opinion. Star Trek better than Star Wars. Now, despite having just done this talk, David, I completely agree with you. I like Star Trek more than Star Wars. I like Star Wars plenty, but I like Star Trek a lot more. Although I like Doctor Who more than any of those guys, because Doctor Who is officially, if you look in the dictionary, best TV series ever made. It's actually official. It's in the dictionary. Look it up. Okay, still listening, just filling in the back for feedback form. Oh, that's very sweet of you. B for Vendetta. Ooh, Now, that was spoiled for me a little bit because I read the comic first. If you haven't read the comic, you absolutely should, because it's brilliant. That is, I don't know if you can see, I don't know if you can see my camera. There's my V mask at the back. Now, that's there because I really, really like the comic. But I was not keen on the film. It had its moments. There were a few bits I liked a lot, but I thought the film missed the point rather. It doesn't help that the book was very much the comic was very much sort of lodged in 1980s British politics, and so there is that sort of link that's missing from the American one, which changes its. I call Doctor Who, Star Trek, Star Wars. I think Star Wars series like Mandalorian, Rebels, about the films could be. I saw 2 episodes of the Mandalorian and liked it a lot, so I probably agree with you there. I need to see some more Mandalorian. Never seen Rebels though. It looks a bit cartoony, but I've heard it's good. I'm expecting to get kicked out any minute now, although I'll still lurk around in the chat window for a bit. Oh, yeah, that's it. Mr. Stoker has called time, gentlemen, please. Yes, I will be around. If you want to chat, ask more questions, whatever, I shall be around. So please feel free.